Picking up where we left off. Let's fix this. You have vertical stretching and shrinking, and horizontal stretching and shrinking. And you know when it's horizontal with the function if the number is inside with the x. And when I mean inside, I mean like inside of the absolute value, inside of the square root, inside of a I don't know, like a greatest integer function. That's how you know it's going to be horizontally stretched or compressed versus vertically. Okay, because vertically means the number is going to be where? On the outside. Okay, so that's one way you'll be able to look at the function and tell the difference. Okay, not so much with the graph. Okay, because a horizontal stretch has the same effect on the graph that a vertical shrink would have on the graph. Or horizontal shrink would have the effect on the graph that a vertical stretch would. Okay? So that's why you can't really tell from the graph. But if your number is between 0 and 1, you're horizontally stretching. And if it's greater than 1, you are horizontally shrinking. So what I did with you guys yesterday was this part of the equation. I should have done this part. Okay? Because technically this is the number that's letting us know there's a horizontal stretch by a factor of what? Not a half, but 2. So I'm going to multiply all of what values by 2? The x's. It should have been 2 and not 4. Okay, I should have looked at this one right here. This is the one that does the effect. I don't square the number to figure out how exactly it's going to be stretched. So that means all of my x values that are on my parent function are going to be multiplied by 2. So 0, 0 will stay 0, 0, but 1, 1 will become 2, 1. 2, 4 will be 4, 4. So remember, all of my x's are getting multiplied by 2. I'm going to watch. And it's going to be the same thing on the other side. Negative 1, 1 will become what? Negative 2, 1. And negative 2, 4 will become negative 4, 4. Okay? And this has what type of symmetry? A review from the other day? Y-axis symmetry. Who said that? Say your name. Yes, good job. I wasn't looking. I knew it was from that side. So that's how it should have been. It shouldn't have been as stretched out as the other one was because I used the wrong number. So do forget it. Similar process for a horizontal shrink. Okay? Horizontal shrink is like we're going to be pushing our hands together to shrink it horizontally. But I'm not going to multiply my x's by 4. I'm going to multiply them by what? 1 over 4. Because remember, anything dealing with your x's is always the opposite. Think about it. When we moved it left and right. When it was plus a number, we moved it to the left, and minus a number, we moved it to the right. Same type of concept. It's the opposite. Okay, so we got to flip that number. 0, 0 will stay 0, 0, of course. That's always nice. But 1, 1 would be 1/4 1. 2, 2. It'll be 1/2 2. I'm multiplying all of my x's by 1/4. 3, 3 would be 3 would change to what? What's 3 times 1/4? 3/4. 3. Okay, so all these are really, really close, in between 0 and 1. Well, 4 would be 1/4. And this one also has y-axis symmetry, so it's the exact same thing on the other side. And there you go. Make sure you're making your graphs nice and neat. Make sure you're making them nice and neat. So there it is. Now can you guys see it being pushed together? Okay? Horizontally. So I basically took the sides and I'm pushing them together. If I'm stretching them, I'm taking the sides and I'm pulling them apart. I'm stretching it. But it has the same effect if you're doing it vertically. Questions? So, like I said before, you guys are going to be able to determine parent functions and transformations of those parent functions. And we've gone over all of them. Now we got to put them into action. So here we go. I messed up on this one when I copied and pasted it over. Okay? But you might have a question like this that says, identify the parent function f of x of g of x. So you would not be given this part right here. Okay? You would only be given the function. And you need to be able to look at the function and say, the parent function of this would have to be the square root of x. Now I know it's right there on your paper, but you're going to have to be able to identify it. But there are key signs to know what parent function you're dealing with. If you see this anywhere in your function, you know it's going to be the square root of x. If you saw something like this, you know it would be absolute value. I mean, they're key things. If you saw something like this, it's going to be a what? A quadratic. So I'm telling you, each one has its own distinct feature. Okay? So, it might ask you to identify it, so then you would just write down what the parent function is. And like I said, I know it's already on your paper. Okay, but I'm still going to go through it. Then it might ask you to describe how g and f are related. That basically means what happened to your parent function to get your g function. That's when the transformations come in. You have to figure out, okay, did it move left, did it move right, up, down, did it get reflected, did it get stretched, did it get shrunk? And you gotta look at all the key features here. This -1 would mean what? It moved, careful, it moved down 1. And you know it's down because that -1 is not underneath the square root. If it was underneath, then it would have moved right. What does that negative underneath the square root mean? It flipped over the y-axis because I made all of my x's negative. It reflected over the, what's it, x? Y. It flipped over the y-axis. So that's what it meant. That's what it means to describe. Then you would actually graph them on the same axis, and they're already graphed for you on the same axis. But your parent function, you can either use the coordinate points that that we graph together. You can use your foldable while you have it, but at the end of the day, you're going to be committing these to memory. Because the more easily you know them, the easier it will be to transform. Okay? So you take each point, you will reflect it over the y-axis, so it's not going to go nowhere at this point. And then you move down 1. And there it is. 1, 1. It gets reflected over the y-axis. And then it moves down 1. 4, 2. That gets reflected over the y-axis and then moves down 1. Does everybody see how that other graph came to be? So that's what you do. Now let's do one. Raise your hand if you think. Don't shout it out. Raise your hand if you see what the parent function is. Who can tell me the parent function with a raised hand? Shout. The absolute value. So I would write that f of x equals the absolute value of x. There you go. Simple as that. Didn't give away those bars right there. Now, I have to describe how they're related. What happened to f to get g? What transformation was performed? Jamie, give me one of them.
It would go to the left 4.
And how do you know it's going to the left 4?
Because in the absolute value bars, it says +4.
The absolute value bars, that +4 is on the inside. You're adding 4 on the inside, which means you move to the left 4. Who can give me the other one? Okay. You gotta tell me, horizontally or vertically? Careful. The 0.5 is on the, which means it's gonna be vertical. Okay? If the number's on the outside of the absolute value or on the outside of the square root or on the outside of the parentheses, it's going to be a vertical stretch or shrink. What's A? Is it greater than 1 or in between 0 and 1? In between, so it's going to be a stretch. By a factor of what? Is it going to be 0.5 or is it going to be 2? 0.5. When it's vertical, it stays true to the number. It's horizontal when you flip it. Okay? I don't know. I'm looking at y'all. Okay, help. Correction. Shrink. And now it's time to graph. Once you commit these parent functions to memory, you will be able to graph all of the parent functions. The absolute value starts at 0, 0. And be careful, your scale goes by 2s. Okay, JP, check slam. I know you got. Your checking scale is by 2s, okay? How does absolute value go? Parent function. It's like 0, 0, then 1, 1. It's 1, 1, 2, 2, 3, 3, 4, 4, and so on and so forth, okay? So you have to graph both of these on your graph. How will the teacher know which one is which? You are going to label which one is which. This is F of X. Now we have to translate it. Transform it, Now, depending on how good you are, some people can go straight from the parent graph to the final answer. For others, you might have to go piece by piece. Okay, for me right now, showing you, I'm just going to go each transformation at a time. Okay? You can do it based off the parent graph, or you can actually take the points and alter the points. Okay? Because anything that relates to the inside affects the X, anything on the outside affects your Y. So, you always do your stretching or compressing first, and then you're moving after. So this 1/2, this 0.5, does that affect my X's or my Y's? Y's, because it's vertical. So I'm going to multiply all my Y's by 1/2. So 0, 0 stays where it is. But 1, 1 goes to what? 1 and 1/2. 2, 2 goes to 2, 2 goes to what? Okay, here we go. 2, 2. I'm multiplying my Y's by half. So that's 2, 1, right? I'm sorry. Let's use this one that's actually on the graph. 4, 4. It's going to turn into what? 4, 2. So I'm just doing this so bad because I'm not hearing y'all's points here. Like, I really don't even want to write this part. That's why I'll keep doing it. I'll get used to it. All I'm doing is I'm taking all the Y's and multiplying them by 2. So that is going to be 4, 2. What about 6, 6? What does that change to? 6, 3. And let's do one more. 8, 8 changes to what? 8, 4. So when I graph these, I have 4, 2, 6, 3, 8, 4. There it is. Okay? I want to do the exact same thing on the other side. Bam.
How are you getting like 4, 4, 4, 6, 6? How do you know?
These are all the points that are on your parent function. That's how you're able to graph the parent function. Okay? If you ever forget what it looks like, remember you can always plug in points. Make a T-table. Plug in points for X and get the corresponding ones. And since it is even symmetry, it's going to be the exact same thing on the other side. So those yellow dots, except that one's on the big one, represent my graph being vertically shrunk by a factor of 1/2. But I'm not done yet. What else do I have to do? Move them left 4. So every point has to move to the left 4 units. Careful. Your scale, because it's by 2s, I'm not going to move over 4 spaces. I'm only going to move over 2. So 2, 2. I'm gonna move left. Everybody see how I just moved those over 4 units? I know it's only showing 2 on your graph, but that's because your scale is by 2s. Your scale is by 2s. So every point moved over. And we'll continue the same pattern. And there's your geometry. Questions? Yes.
So you do like stretch, the strength, then the right?
Yeah, so you do any of your dilations first and then your translations. Okay? So I had an order. I will go dilations, reflections, and then translations. You know, take this little video. Let's do the next one. Raise your hand when you think you have the parent function. Raise hand, who can give me the parent function? Marshall. F of x equals x squared. Did I give away? That's squared. Now, describe how they are related. How are they related? Okay? How are they related? Who has it? The raised hand. Who has one of the transformations? Alexis.
Right.
Careful. With quadratics, okay, you'll be able to tell whether it's up and down or left and right because they will put in a set of parentheses to represent that. So it's actually down. Okay? With a quadratic, that's what right 4 would look like. Does everybody understand that? And then, of course, left would be, plus. So that 2. What's that 2 do? Okay, you gotta give me horizontally or vertical. Start with that. Horizontal or vertical? Okay, it could be a vertical stretch by a factor of what? Or it could be a horizontal what? Now you guys sure about the stretching and shrinking? You're telling me that because that number is greater than 1, it's a stretch, right? Okay. Now the reason why it could be either or is because since there's no set of parentheses here to say that, okay, well this 2 is on the inside or the 2 is on the outside, we don't know for sure exactly which one it could be. So if half the class put vertically stretched by 2 and the other half put horizontally shrunk by 1/2, technically, based off of this, both groups would be right. Okay? The only time when accepting both answers would not work is if you had something like this and the 2 was clearly on the outside. Okay? Or if you had absolute value and the 2 was clearly on the inside. Okay? So, when you graph this, your choice. Do you want to vertically stretch it by 2 or horizontally shrink it by 1/2? So raise your hand if you like fractions. So I probably would opt for the vertical stretching. If you like fractions though, I mean I like fractions. So what we're gonna do, we'll do y'all first. Graph this parent function. Graph that x f of x equals x. Yeah. Over there on the desk. There should be a distinct difference between your absolute values and your quadratics.
So we're going down 4?
We are going down 4. But after we vertically stretch it. Remember, you always do your stretches first before you do any of your, you do any of your dilations before you do any translations. Okay? You're multiplying all of your y's by 2. You're multiplying all of your y's by 2. So 1, 1 would now be where? 1, 2. 2, 4 would be where? 2, 8. And then 3, 9 would be too high. Negative 1 of 1 would be negative 1, 2. Negative 2, 4 would be at negative 2, 8. The yellow dots represent my parabola vertically stretched by a factor of 2. Now all I need to do is move it down. So I'm going to move every point down 4 units, being careful of my scale. So 0, 0 moves down 4 units. 1, 2 moves down 4 units. 2, 8 moves down 4 units. Does everybody see it? Move it down 2 units. Move it down. And there is the graph of G. Make sure you are labeling your graphs. Questions? So you can use your parent graph to graph any of your transformations. In my personal opinion, I think it's the easiest. The only other way that you could do this, possibly, is by taking the points instead and doing all of the alterations to the points. Okay? But the thing is, you still would need to know what the points were of your parent function. Okay? So right now, on the paper I just handed out, I want you guys to practice. You're going to graph numbers 1 and 2. If you get stuck, use your foldable. Ask your neighbor, okay? But you're graphing those two, number 1 and number 2, on the sheet I just gave you that says prep work on it. So number 1 was a square root function. This is what it looked like, the parent function. And you had x plus 3 plus 1. What did that plus 1 mean? What did that plus 1 mean? I had to move every point up 1. So every point had to go up 1 unit. And then that plus 3 underneath the radical meant what? I had to move to the left 3. Think of it like this. Anytime something is being added, a number is being added to the parent function, that has to be a translation, either up, down, left, or right. If a number is being multiplied to the parent function, that has to be a horizontal or vertical stretch or shrink. If there's an extra negative that's not a minus sign, those are your reflections. Okay? So now everything has to move to the left 3 units. Left 3 units. Left 3 units. And there it is. Now if you went left first and then up, that's fine, you still get the same thing. Yeah. I don't know why I went up first. I should have went from inside out. But raise your hand if you got this. Good stuff. The next one was what type of function? Absolute. We've done this enough times, I feel. Parent function 1, 1, 2, 2, 3, 3, 4, 4. Please again, make sure your V's look like V's and your U's look like U's. That was it, right?
Yeah.
What did that negative mean? I flip it over my X. And that 2, it's not on the outside, it's on the inside, which means it's vertical or horizontal. Stretch or compress. Stretch or shrink, sorry. Shrink. Okay. By a factor of what? 1/2. So that means that all of my what are getting multiplied by 1/2? All my x's. Remember, horizontal is always the reciprocal.
Oh, okay.
So 0, 0 stays there, but 1, 1 turns into 1/2 1. 2, 2, 1, 2. 3, 3, 1.53. 4, 4, 2, 4. And then every single one of these points is getting what? Over. So I'm reflecting it over the x-axis. 0, 0 stays where it is. So nice to have 0, 0 sometimes. And then everything's getting reflected over the x-axis. So that means it is upside down. Please make sure you're drawing your graphs nice and neat. Question?
Is it okay if we didn't do the yellow? Like, what I did was, I wrote down the parent function, and then I just multiplied all the y's by a -1 and all the x's by 1/2.
Mm-hmm.
And then do x and y table, and then graph.
Oh yes, that's what I was saying before. Another way you could do it is you could take the points, and if you know what type of transformations are happening, then you can apply it directly to the points. If I'm reflecting over the x-axis, that means it makes all of my y's negative. So that means that all of these are going to be negative. And then multiplying by 1/2, that means all of these are getting multiplied by 1/2. That's -1. That's -0.5. That's 0. Positive 1.5. And then now you have your new points that you can graph. That's another way you can do it. Either way works. Either way works. Questions on transformations? Back to your notes. Now we're going to write the equation. It already gives us the graph. And now we're going to write it. It's actually a little bit easier. You still do the same thing you did before. Write out the transformations. Look at the graph. Here's the parent on the left, the new graph, h of x, on the right. Clearly something happened. One person raised their hand and tell me, give me one transformation that happened to this parent function right here. One, raise hand, you turn it. It went down. How many units? One or two. It went down 1. Because the scale is by ones. Raise hand. I'm not doing the shout out thing. There's one more transformation with the raised hand. Aiden. It shifted to the right. 2. So that's how you describe how they're related. Now it's time to write this function. I have to show that I went down 1 and right 2. Okay? Riley.
Can I say what it is?
Yes.
Absolute value of x plus 2. And then take the absolute value minus 1.
Okay. So right here, it's an absolute value parent function. That's for sure. So you gotta have those in there. Since I'm moving down, that -1 needs to be on the outside. And then I'm moving to the right 2 units. This is one thing you gotta be careful of.
It would be -2.
It would be a -2, because remember, on the inside, it's the opposite. So it should have been x minus 2. Right there. After you write your equation, just double check to make sure that you're using the right signs, especially when it comes to the anything dealing with the x's.
Why is it -2?
Because remember, on the inside, everything's the opposite. So minus means moving to the right, positive means moving to the left. Look at this one. Don't shout it out. Just want to ask for a volunteer here. The raised hand. See if you give me one of the transformations. There's a reflection over the x-axis, because clearly it's not shooting up into the first quadrant, it's now shooting down into the fourth quadrant. So a reflection over the x. And there's one more, shot. And it moved to the right 2 units. I have to represent that. As a function. Unless you want to do it. It's a square root. Okay, take in pieces.
Oh, negative square root.
Negative square root? Yes. Okay, so there's the reflection over the x-axis, negative square root.
X minus 2.
Now that minus 2, is it underneath the square root or is it on the outside? Underneath. Very good. And there's the function. Yes.
So the minus 2 then. It's how it was for absolute, it's the same thing for the square root.
Uh-huh. All absolute, square roots, greatest integer, cubic, all those mean to the right 2. That's how you represent that, to show the difference between the inside and the outside. Okay? Look on that paper that says prep work. You're doing number 3. You're doing number 3.
If it goes up, diagonal divide plus. So if it brings over 1 or you move up 1 to plus 1. So at one point there's going to be plus 1. You know that.
What happened? What happened? Anissa, tell me something that happened to the original paragraph. It went up 1. Wait, question, what was the paragraph? Stephen, what's the paragraph here? It was just x squared. X squared looks like this. Real quick. That's what x squared looks like. So it went, you said, what? It went up 1, okay? Something else happened, Kiana.
Went to the right one.
It went to the right one. So up 1, right 1, and there's one more thing that happened, Tiffany. It reflected over the x-axis. That's why it's pointing down now. So you had to write a function to represent this. Was it H or G? It was G. Top.
You got it.
There you go. Good job. Good job. That square needs to be on the outside of parentheses so that way you know for sure it's being moved left and right. If it was on the inside, then technically you would have a down 1 and then an up 1. So they like contradict themselves. Okay? Questions?
Oh.
Last thing on this lesson. I told you at some point in time, you're going to have to graph these. But now that you know what they look like, it's a lot easier. It is a lot easier. Okay? At least that's what my last 2 classes said. So I feel like it's going to be 3 to 3. Here we go. Break it into pieces. It's what? And so it should look like a what? A V. Just to confirm, everybody has a pencil, right?
Yeah.
Okay, because the way I'm going to do this is I'm going to draw the full thing out and I'm going to erase certain parts. So I need to make sure you have that erasing capability. Okay? We're back to the notes. So it's absolute value. Everybody knows absolute value. You know 0, 0, 1, 1, 2, 2, 3, 3. I think we've done it, I think, at least 4 times today. Okay? There it is. In yellow. But that plus 2 on the inside of the absolute value means what?
It's going to the left.
It's going to the left 2. So every point moves to the left 2. Left 2. Left 2. Okay, that's what we just practiced graphing, right? So this is the function x, absolute value x plus 2. But the thing is, I don't want the entire absolute value function. I only want the part where x is less than 0.
You want it from
So I want it from
right up.
where?
You going right up.
Right here?
Yeah.
All the way, I want everything from here,
Over.
which way? This way, this way.
That way.
The left. I want everything from the left of x is 0. So I'm going to go back and I'm going to erase what I don't need. And why do I need an open circle? Because it's not included. And there's that piece of your piecewise function.
So we don't need the actual, the real one.
I just kind of use that as a reference to give some more practice. Some of you guys can honestly you can take the point and just move it over. That's why I just did dots.
Why do you stop at that line again?
Because of the interval restriction. We're only concerned about those values. Other questions? The second one is another absolute value. This time I'm not moving left to or right to. I'm moving down to. So every point moves down 2 units. If you notice, I'm going to overlap with this part. But I only want the ones that are from 0 to 2. So from x equals 0, which is right here, to 2. So I only want this portion. So I'm going to erase everything else. And I need a what? A closed circle. On 0? Yeah. On 2? And there's the second piece. Questions so far? The last one is not an absolute value, it's a what? A square root. Classic square root looks like this. But I'm moving it how? What does that minus 2 mean? Right 2 and the plus 2? So every point is moving to the right 2 units and up 2 units. Oh, open circle? Because it's not defined into right 2, up 2. Right 2, up 2. And there's the square root function. And that's it.
That is so.
It's really not different, it's just they're combining 3 graphs into one.
Combine 3 graphs into one and erasing the parts that you don't need. Okay? Questions on piecewise? You want to do one more?
Let's do number 4.
You want to do the one to the left or the one on the right?
Let's do the one on the
Go
right.
to the left.
On the left because of the scale.
On the left? Because the scale. Okay, well, if you're going to do the one on the left, you got to make a change. That needs to be a cube. Which I think is good. We have not graphed the cubic yet. So I think it's good for us to practice graphing all of our. So we're making a change. So that last one is going to be a cube, not a square. So let's get graphing. The first one. What is it?
It's a
Quadratic. Class quadratic. 0, 0. 1, 1. 2, 4. The other one is not in the picture. What does that 3 mean? 5 factor of? Is it a vertical stretch by a factor of 3 or a horizontal by a factor of 1/3? But we want to do stretching, I'm guessing. So we're going to stretch this by a factor of 3, which means that all of my what values get multiplied by 3? The y's. So 0, 0 stays 0, 0. But negative 1, 1, negative 1, 3. Negative 2, 3 turns into, so, my bad, negative 2, 4 turns into negative 2, 12. It's like all the way up there. Same thing on this side. All the way up there. So this is my parabola, roughly. But I don't want everything. What do I want? negative 1. So I'm erasing everything else. And what should happen at 1? Should it be a closed circle or open? Open. There you go. That's that piece. F of x equals negative 1. It's a horizontal line. What's the parent function? No. 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 That's a linear function. You're looking for the constant functions. Let's see. This is a horizontal line that crosses the y-axis at negative 1. But I only want the values that are from negative 1 to 4. Do I have a closed circle or open circle at negative 1? And what happens at 4? I would love a piecewise function full of constant functions. Horizontal lines everywhere. So we got the first 2 done. Cubic. If you forgot what a cubic looks like, plug in values. When I plug in negative 2 into the cubic function, what do I get? Negative 8. When I plug in negative 1, what do I get? I plug in 0. When I plug in 1. When I plug in 2. So I got a super high number there, super low number here. So it goes, forgot what a cubic looks like? You remember now? So what's happening to this cubic function? What's that minus 5 mean? Right 5 and then up 2. So these points are moving right 5. 1, 2, 3, 4, 5, up 2. 1, 2, 3, 4, 5, up 2. This point, 1, 2, 3, 4, 5, up 2. This point is all the way out there. But I need to make this look like a cubic. I only want everything that is greater than or equal to 4. So it's a closed circle here. And then I make my cubic after that. There you go. There's this piecewise function.